4.1 Extreme Values of Functions, Part 2. Your objective for this lesson is still to find extreme values of functions. Okay, example 5. Find the extreme values of f of x equals 5 minus 2x squared for x is less than or equal to 1, or x plus 2 when x is greater than 1. So let's look at our graph quickly. So 5 minus 2x squared, or x plus 2. Our changeover point is at x equals 1, which is right there. So it looks like for the first half we have an upside down parabola, and then it just shoots off into space. So it looks like for this one there will not be an absolute max because this line's just going to keep going. Looks like there is a local max at x equals 0. I'm going to say a local min at x equals 1 and no absolute min because this side of the graph will keep going down forever. So analytically, let's look at this. If I want the derivative of the function, f prime of x will be, for this first part, negative 4x. That's x is less than 1, or derivative of x is 1, for x is greater than 1. And this, notice, is not defined at x equals 1 because those two derivatives are not equal. Since they are not equal, there is no derivative at x equals 1. The derivative is not defined at x equals 1. Of course, that does mean that there is a critical point at x equals 1. So x equals 1 is a critical point. That is important. So let's see if we can set f prime equal to 0. So when does f prime of x equal 0? Well, for this bottom part, it's never going to equal 0. It's always equal to 1. But this top part, negative 4x equals 0 when x equals 0. Okay. And okay, let's go ahead. So this is a second critical point. Let's go ahead and look at what's going on at our critical points back in the function. So if I took x equals 1, I would plug that into the top part of this function, and we would get 5 minus 2 times 1 squared. So 5 minus 2 is 3. So we're looking at the point 1, 3. And at x equals 0, we're also going to use that top function. So 5 minus 2 times 0 squared is simply 5. Okay. And from looking at my graph before, I know that 1, 3 was a local max. Oh, sorry, no, a local min. So I have a local min at 1, 3, and I have a local max at this other point here, 0, 5. So this was the, okay, like this. So this was 0, 5, and this is 1, 3. Example 6. Find the extreme values of f of x equals ln of x divided by 1 plus x squared. doing this graphically first. So we have, where is it? ln of absolute value of x divided by parentheses 1 plus x squared. Okay, there we go. So we can see that this is an even function, and looks like I have two maxes, there and there, and some sort of a min at x equals 0, but no absolute min, perhaps. Okay, let's take a look at this analytically. I know that I need to find f prime. And to do that, I'm going to have to use my definition of the derivative of ln. So derivative of ln u is 1 over u times du dx. Okay, so f prime of x is 1 over x over 1 plus x squared times d dx of all this stuff. Okay. And when I have 1 over something, I know that I can just flip it over. So 1 plus x squared over x. And for this derivative, I'm going to need to use the quotient rule. So this is my u, this is my v, high and low. And I have low d high minus high d low over low squared. So 1 plus x squared times 1 minus x times 2x over 1 plus x squared squared. And okay, let me simplify what I have in brackets here because that is a lot going on. So I have, if I multiply my 1 in here, I just get 1 plus x squared minus 2x squared over my 1 plus x squared squared. Okay, but x squared minus 2x squared is a negative 1x squared. So 1 minus x squared. Okay. Now I get to multiply these straight across, but before I do that, I can cross cancel this and one of those. So I'm just left with 1 minus x squared over x times 1 plus x squared. Okay, so this was my derivative f prime of x. Okay, so a few things here. What I want to do, remember, is take this function and set it equal to 0. And this will equal 0 where the numerator equals 0. So 1 minus x squared equals 0 would give us 1 equals x squared, which is x is plus or minus 1. Okay, so these are critical points. There are also critical points where this is not defined, which is where the denominator equals 0. And I can see right away one of those points would be at x equals 0, and then 1 plus x squared is never going to be 0. So only at x equals 0. But that's not part of my domain of the original function. So because then I would have ln of 0. If I plugged in a 0 for x, I would have ln of 0. And ln is not defined. You cannot take ln of 0. It has to be a positive number. So this isn't part of the domain of my derivative, so I don't really have to worry about x equal to 0 there. So, but I do have to worry about plus and minus 1. So I am going to plug these into f. So f of 1 is going to be ln of the absolute value of 1 over 1 plus 1, which is ln of 1/2. And for negative 1, I have ln of the absolute value of negative 1 over 1 plus negative 1 squared is 1. So I still have ln of 1/2. And that is approximately equal to negative point, what is it? So ln of 1/2 or 0.5, negative 0.693. So both of these are approximately negative 0.693. And if we looked at that graph one more time, we'll see that those are absolute maxes. And that is at x equals plus minus 1. And it equals ln of 1/2. 1/2. Okay. And that concludes 4.1.